There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and solarium, and bismuth, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury and molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, radenzine, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Okay.
Hello, you have been assigned to design a box.
With a square base that must have a volume of 1,000 cubic centimeters.
Now go and design that box. Oh
Okay,
wait,
now
and
the-
also the top and bottom of the box will be made of gold foil. This will cost $100 per square centimeter.
And the four sides are made of brass and will cost $5 per square centimeter.
And remember, you're paying for the foil, so so you might want to make it the cheapest
Okay,
way
so
possible.
we want to make H and A such that the cost of the box is a minimum. Now remember, the gold is $100 per square centimeter, the brass is $5, and the volume has to be 1,000 cubic centimeters. So, given that, we're going to just use this. The cost will be $100 times the surface area of the top and bottom, and plus $5 times the surface area of the sides. Now remember, there's one top and bottom, so there's two, and the area of the top and bottom is A squared times 100. That's the cost of the top and bottom. There's four sides. The area of that is AH, and $5. So that's the cost. Now, we have two variables here, A and H, and so I'm going to get rid of H by the fact that the volume is 1,000 cubic centimeters. So H equals 1,000 over A squared. I'm going to substitute that in, and this is the equation that we get. Okay? Now, you see I have an A over A squared, so that will give me 1 over A. So that results in this equation. The cost is the cost of the top and bottom, 200A squared, plus the cost of the sides, 20,000 over A. Okay, now there are two ways of solving this. One way is using calculus. So let's look at this equation, and you know that when you have a cost that's going to vary, it's going to reach a minimum, the minimum cost. And if we were to plot cost versus A, we would get a curve that will show a minimum, but we want at that minimum the derivative, the slope, is 0. So let's take the derivative of this equation. The derivative of this equation with respect to A, dc dA, is equal to 400A minus 20,000 a to the minus 2 equals 0. Now this is an easy equation to solve since there's only one variable A. So we multiply both sides by A squared to get rid of this A here, and solve for A, and we get A equals 3.684 centimeters, about 3.7. And then we could substitute into the requirement that the volume is 1,000, and solving for H, we get H is 73.682 centimeters. And then we can go into the cost equation and very straightforward find the cost as $8,143. Now this is a long, tall, skinny box, but it would have the minimum cost. Now, if you didn't know calculus and you wanted to do this in another way, you could use a spreadsheet. So I'm varying A from 0.1 up to about 20 and calculating the cost. Again, I'm keeping the volume constant, so H is determined by what A is. When A is small, H is large, and vice versa. And so I plot this, and you can see that the cost comes down, reaches a minimum. At that point, the slope is 0, and then goes up again. And you can see that minimum occurs about 3 point something. But I actually, on this, determined what the minimum was. It's 3.7. You know, if I broke it down into smaller points, it would be 3.68, whatever I had on the previous calculus derivation. And the cost is $8,143.21. So you can understand how calculus and the graph are related. The slope, first it's a negative slope, then it goes to 0, and then it's positive. It's 0 at the minimum. So this is Chemical Charlie and
This is
Hi, Guy. Pepin signing
you still
off.
have to make the box
Okay,
and pay for it.
so thank you.
Don't forget to pay for it.